very warm
That's very
welcome
good.
to you. I'm very happy to introduce you to Jim, my colleague. Jim is our head of circular economy. I would have a full bio, but I don't want to take up all of the time of the webinar to read it for you. All I say is Jim has been involved for many years with the Ellen MacArthur Foundation in Europe to actually co-develop the methodology for the Material Circularity Indicator. He's also been a co-author of the ISO standards that have recently come out. So we feel ourselves very lucky that we've got Jim on board with us. And I will hand over to him very, very soon. Some of you also might not know us as an organization. So we are thinkstep-anz, a team of about 45 people working on any topics right from sustainability strategy to detailed life cycle assessment, carbon footprinting through to communication, and of course, circular economy, which brings us to today's topic. My name, by the way, is Barbara. I'm the CEO of thinkstep-anz. I'm your host for today.
Excellent. Thanks, Barbara. I'm Jim Goddin. I'm the head of circular economy at thinkstep-anz. I've been with the business for the past 5 years. As Barbara says, I've been working in the area of circularity metrics for the last 15 years. So since the Ellen MacArthur Foundation started, we started discussing circularity metrics and the need for them. So that's what we'll take you through today. So what is the MCI? For those of you who are new to this area, it's a methodology that was published by the Ellen MacArthur Foundation initially in 2015. As we started work on it before that, we adapted it to include biological materials in 2019, and there have been a couple of more recent small additions that have been added in as addendums. But it's the leading solution to a very specific problem, which is the comparability of circular models. So if we look at the different models that exist within the circular economy, whether that's durability, reuse, remanufacturing, recycling, composting, in some cases energy recovery, or the responsible sourcing of biological materials, all of those are measured differently. And that makes it very hard to compare different circular strategies or to understand the combined benefit of different strategies when used together. So you might use responsibly sourced biological materials in a durable design with the intention of sending those materials to be composted at the end or reused. How do you understand the net benefit of that in terms of decoupling from the consumption of non-renewable materials and the production of waste? So what the MCI does is it takes all of those different models that exist and produces a single metric that ranges from 0%, which is a fully linear system, to 100%, which is a perfectly circular system in which there's no non-renewable materials being consumed and no waste being produced. The advantage for this metric is that it is comparable across all of those different models and combinations, which means you can use it in a whole host of different ways. So how it's used today, it's used for designing, so for designing products and understanding the impacts of design decisions on circularity from a very early conceptual stage through to full design. It's used for benchmarking products to understand how circular an existing product is today, to compare products. So because you have all of those different strategies applicable across all the different materials, you can directly compare different options. You can use it to develop strategy, and we have a number of clients who are doing that. And increasingly, we're seeing it being used to communicate publicly on the circularity of specific products. And there are a number of schemes coming in that I'll mention next. So it's being used in a whole host of schemes and has been adopted by things like Green Star here in Australasia and the Infrastructure Sustainability Council. So both of those now have credits available for the use of the MCI. It's indirectly used in BREEAM. I say indirectly because BREEAM aligns with the ISO 59020 standard, which you see there on the right, and adopts some parts of the mandatory indicators within that standard, which are actually informed by the MCI. So as I said, the ISO standard has, although it was developed after the MCI fully aligns with the standard and gives a way for us to take those indicators within the standard and to turn them into something that is individual and communicable as a single metric rather than as a host of individual metrics. It's also used by most of the major LCA platforms, and an increasing number of digital product passport systems are also using the MCI. So we're seeing quite a broad spread of adoption for this particular metric. It is also the only circularity metric at a product level, at least, that's been published today. So over here, we have 160 products with verified published MCIs in their EPDs today, and there's a whole pile more that are coming. So these range from steel to ply and particle board, asphalt, insulation. There's a whole host of different materials, and you can see on the left there a representation of some of the typical spread of the circularity that's being reported in those EPDs. Now, the reason I put this up here is because it shows how we can use the MCI to compare completely different solutions. So on the left, you have steel, which is using recycled content and recycling at the end of life, and the range of MCIs that come out from that. We have ply and particle board, which are leaning heavily on regenerative sourcing, so using things like FSC certified timber, but have a limit to what they can do in terms of the recovery of those materials at the other end, because they're a hybrid between a biological and a technical material in a lot of cases. And we have asphalt, which has a very wide range from highly linear mixes, which primarily primary materials that are being used, through to mixes which are using a larger proportion of recycled asphalt and polymer blends to increase the recycled content. And that, coupled with regional recycling of asphalt, gives it those higher ranges. So we have a whole host of different solutions with different strategies within them and different materials, and we can compare them directly. So it provides a very useful benchmark for these types of products to be picked up and used by projects. So what is the MCI Pro? Yeah, it's intended as an inexpensive professional declaration-ready tool, and I'll go into what that really means next. So we have a free version of the MCI tool that's available on our website and has been for a year or so now. And these are some of the most common requests we get for that free tool. A lot of people want better instructions in terms of how to use it. They want to be able to add their own custom materials and to add more parts to larger bills of materials. They want decision grade results and publication ready reports, improved guidance in terms of how the methodology works. And a number of people also want support for other languages. So the tool so far has been primarily in English, but we have a lot of downloads from regions which are not native English speaking. And so there's a preference for other languages as well. So we'll go into how we've delivered each of those items next, to give you an idea of what the MCI Pro tool actually includes. And some of it's really quite exciting. At least I think so. So in terms of better instructions in the MCI Pro, there is full step-by-step guidance in terms of how the tool works and how to use it. We've also created an abridged version of the MCI methodology. If any of you have read this, it's quite a long document. And so we've really captured the key steps in the MCI calculation and provided those both within the tool as a standalone tab that you can read through. And that's now available in each of the languages as well, so you can access that in your own language. But we also have a standalone need to know on the MCI methodology, which is in English, but it gives you a much more robust and well-designed document that you can print off or have on screen next to you as you work through it. We also have links within the tool if you want to book a call for extra help if there's anything that's unclear, or if you want some assistance, or if you just want to talk through how you're using it and how it applies to your particular model. You can contact us directly from the tool. Now, the free version and the Pro version both have a built-in reference set of materials. The reason we did that is because it's a barrier to getting started. We want people to be able to get right into adding their bills of materials and understanding their circularity very quickly. So there is a reference set of 46 materials that cover common plastics, construction materials, packaging materials, textiles, and some other things like electronics and other materials. All of the data in there is intended as global reference data, so it's not specific to any one region, but it can all be replaced by your own data. So in the screenshot on the right, you'll see the white cells. You can put your own data in there if you want to use a different figure, and that will be used in preference to the reference figure that's provided. Now, in the MCI Pro version, we've added additional waste factors, which make the calculation a bit more comprehensive. We've also added a separate tab where you can add up to 100 of your own materials. So you can go beyond the materials that we provided and specify your own with your own names, which can be completely different materials or different grades of the same material or different suppliers of the same material with different data associated with each. So that gives you the freedom to use data beyond what we've provided out of the box. In terms of the larger BOMs, we also have space now for 100 components. That's up from, I think, 30 in the free version. And we've done that. We've chosen that number because it also means you can have a different custom material for every part in your bill of materials. Most use cases will be covered by 100 lines. Again, in the tool, we have included manufacturing scrap as well. So we have, again, a bit more of a robust calculation that includes other sources of waste production that arise during the manufacture and production of your products. In terms of the decision grade results, the free MCI tool had several simplifications and emissions, which I've mentioned already. The MCI Pro tool includes the full methodology, including the additional waste factors that are specified. So waste from producing recycled content and waste from recycling used products, for example, are now included in the tool. So you can get a more accurate representation of your circularity. We have some improvements to the graphics. So one of the challenges that comes from having a larger bill of materials is you end up with a situation like this on the right, where you have a lot of overlapping data labels. So it makes it very hard to see what you're looking at. We can now filter those by cost, by CO2 and the MCI. So we can really filter down to the key data points that we're interested in. In this case, I think we filtered this by cost. So these are some of the materials that represent a larger proportion of the overall cost of the product, but which also represent an embodied CO2 and in this case have quite a low level of circularity. So these are the sort of components that you might want to prioritize improving the circularity of as part of your strategy. We also have what's called the user influence chart. And this is, to me, really exciting because it takes the MCI into a completely different realm. So the MCI, as some of you will know, is based on three core components. So where your materials are coming from, where they're going to, and how you're using them. So that's what you make it out of, which is determined by the manufacturer, including things like manufacturing waste. So these are things within the manufacturer's control. End of life recovery, as a manufacturer, you can influence that a bit by design and by take back schemes, but it's also influenced by things like infrastructure and user behavior. So some of the contribution to your circularity is out of your control as a manufacturer and will be subject to where the product's being used, how it's being used, and who buy. And similarly for product utility, we have physical and emotional durability of your products combined with user behavior. We can have a good idea of how long we expect a product to last, but how long the user actually uses it for also influences the MCI. So we have an interest in being able to publish an MCI from the manufacturer's perspective that reflects how they've manufactured it and what the intent for that product is in terms of its use and eventual recirculation or recovery. And we need to be able to encourage that and promote that as a way of communicating the potential benefits of a product. But the MCI also needs to inform the user in terms of how their behavior affects circularity. And it needs to be updatable to reflect that user behavior, particularly as we start using these published MCIs as part of larger projects. So let me show you what the user influence chart actually looks like. So this is for a hypothetical product we call the hypo shoe. What we see is this point here, which is the expected MCI. So this blue line references the manufacturer's expected end-of-life recovery, and it shows how that MCI changes as you move from left to right, as you improve the use of that product, so you make it last longer. So we have the expected MCI as this data point here in the middle, which references how you've made it, how long you expect it to last, and how it's going to be recovered in the market you're selling it to. The red line at the bottom is the MCI of the same product if that product were to be landfilled or incinerated. So if you eliminate any circulation at the end of life for the product, the circularity drops, in this case, quite considerably down to less than 10% from 25.3. So it shows what the effect of that behavior is. Similarly, if you are able to reuse the product or recover it completely, the circularity has the potential to jump to 60% in this case. And that's without the manufacturer changing anything about the product and the components that are used within it. As I said, if you move along that line, or if you move along the green line or the red line, you can either increase or decrease the circularity as well. So if you use the product for longer, the circularity is going to increase along that line. So if you get to a 15-month durability in this product, you can expect 40% circularity. If you use the product for, what's that, 8 months, then you're actually undoing a lot of the circularity that the manufacturer has built into the product in the first place. So this chart gives a sort of one-shot perspective on how the user's behavior influences the circularity that's been embedded by the manufacturer. It shows what the potential for improving that circularity is. And it also provides a set of data that sits behind this graph that can be used by larger projects to incorporate the MCI of different products and to adjust the MCI of those products according to how they're expected to be used by the user. So if you're using a timber with an MCI that has an expected service life and expected recovery rate, but you plan to use it in a different way that makes it last longer or improves the recovery rate, you can recalculate from the data behind this graph what that circularity is and use that updated figure as part of the circularity for your project. So it gives a lot more flexibility in terms of how that MCI is used. So I said the user influence chart provides users with much needed context. It shows that circularity isn't a given and that their use of the product influences what the actual circularity will be. And for people who are planning a project or a larger product, it enables them to recalculate the circularity of all the materials they're using to account for design influences from their project onto the components and to be able to see the benefits of how they use those materials reflected in their MCI results. We've also built in a product circularity data sheet. So this is a report that's been defined by the sister standard to ISO 59020, so ISO 59040, which is a machine readable format for communicating the circularity of products. So it includes material inputs by type and by source. So you can see in the bottom right the mass of each material type and where those materials have come from. There's not a lot of reused or remanufactured or recycled material in this particular BOM. We also have a separate table down below which does the same thing in terms of the expected outputs of those materials, tables to capture any hazardous substances and other fields that are machine readable using these unique ID codes next to each of the categories. So this report can be generated automatically from the tool, and you can fill in any additional details you want, and then that can be used to communicate the circularity of your product to other stakeholders. We also have a publication-ready report. So this is an MCI declaration. So this is a report that's specifically designed to be suitable for incorporation in EPDs and LCAs, or also as a standalone report. All of the data within this report is traceable back to the source data and assumptions that you've used in the tool, which then supports verification. So this report is intended as something that will be independently verified before publication. It also contains, as I said, the data that you need to be able to recalculate the MCI if you're an end user. So you can take the report for a product that contains this declaration, and you can then use the data within it to recalculate the circularity of this material as it enters your project. And this report really helps you to tell your story. And there are various fields in there that enable you to tell more about how you're actually approaching the product design and where you're going next. And also, as I said, we have the entire tool available in multiple languages now. Initially, we're supporting English, French, German, Spanish, and Portuguese. So at the click of a menu button on one of the tabs, you can change the entire tool from English to any of those languages. And that includes all of the graphics and drop-down menus and explanations and instructions. So yeah, you can use this tool in whichever language you wish out of those ones. If you want to add another one, we're keen to speak to you. We're looking to collaborate actively with people who want to have this tool in other languages. So do reach out to us if you would like to see the tool in a different language. And with that, I'm going to stop. And I'm looking forward to reading some of the questions. I can see that we've received some already.
I've got quite a few questions for you, Jim. So
That's good.
thank you very much for talking us through that. That was a lot to take in.
It is a lot to take in.
But I'll give you the first question. How is the MCI related to digital passports?
That's a good question. So the MCI is one of the data types that could be used within digital product passports. So there are platforms out there already that, as I said, use the MCI. The reason it's such a good match is because a lot of the data you would need to calculate an MCI would be found within a digital product passport. And the data required is also aligned with the ISO standards, which digital product passports are also aligning with. So it's quite a good match. I mean, the MCI was originally designed specifically to work with a lot of the same data that you would encounter within an LCA in order to be able to lower the threshold in terms of the additional data you need. And it's very similar for digital product passports. So while we're still waiting for some of the confirmation of details for things like the European Digital Product Passport, we're expecting that to align very well with the MCI, and for the MCI to be one of the metrics that can be used within those digital product passports to communicate circularity in a comparable way.
Okay, so thank you, Jim. Let's move to the next one. There are quite a few, so we need to go through them quite quickly. Does the new MCI have comparable lifetime values that compare your own product with a standard product? It's often difficult to compare your product with a standard product on the market.
It is, yeah. And it was a discussion that we had with the MacArthur Foundation at the beginning. We originally wanted to be able to include a reference list. There are some reference lists out there for typical building products, for example, but we haven't addressed that because it is one of those things that is highly contextual. And so we've left it really to the product manufacturer to decide what an equivalent product is. But certainly in terms of the durability, that is calculated as a function of the durability of your product compared to a typical product of the same type. It's just you would need to define what that typical product is and make a justification for that when you publish your figures.
Okay. Stefan actually has quite a few questions. He also would like to know, how would you communicate the MCI? Many end customers cannot yet imagine what it entails. And I think the declaration might help with that a bit, but maybe you
Exactly,
can
yeah.
give us a little bit more insight.
Yeah, exactly. So the MCI, as I said at the beginning, is a single figure metric. So it is a metric that ranges from 0 to 100%. So you can understand what the overall circularity is. In our declaration, we also break that metric down into the three separate components. In fact, it's four components. So we have the raw material decoupling. So that's how much reused, remanufactured, recycled, renewable content that you use and how much that contributes to your MCI. We have waste reduction, which is how much the end of life recovery of your product contributes to the MCI. And then we have the circularity from enhanced utility, which is what we were just mentioning in terms of extending the service life of your product or using it more intensively, which also contributes. So we break those three aspects out. What's left is the circularity gap. So this is the remaining gap between the circularity of your product and 100%. So this is typically how we would communicate the MCI. At the bottom of this particular declaration, we're also showing the MCI under different recovery pathways. So going back to that user influence chart, the 3 points in terms of full recovery, no recovery, and the manufacturer expectations are affected by the MCI on the left and the right and the one in the middle. So we can see how those user decisions will affect the circularity of the product and what you can expect from that. But there's obviously a lot more information in here, which we could go into detail of, but I should probably cut that short. But happy to talk to you further about that if you wish.
Thank you, Jim. Judith has a question. Good to see you, Judith. I know you might be traveling, but otherwise it's really late for you too. Good to have you here in any case. Judith wants to know, do you have any real-life examples where the MCI of a product is being used to improve the product, e.g. the use of more recycled content or similar?
I do have examples. There are probably examples that I'm not permitted to share, but I can talk about them in more general terms. So I'm aware of businesses which are actively using the MCI to understand where their hotspots are in terms of their product. So where individual components contribute a significant portion of the potential circularity of their product, and then using that information to dig into how they can improve the end of life recovery, for example, or reuse of particular components that represent a large amount of their material flow. And some of that can include how those components are coupled. So if you have glass and plastics and metals adhesively bonded, how do you separate those so you can reliably either repair or recover those materials when those products exit their use in order to increase the circularity. So we see examples like that. We can also see examples where a lot of businesses are still looking at how they improve recycled content and what particular types of recycled content they use. We've seen cases where the use of recycled content has actually led to an improvement in durability. So you can either get away with having less of the material, or you can use the material for longer. And those components can also be reflected in the MCI and used as a comparison. So there are a lot of examples of how the MCI is being used to inform decision making and communication. And we're seeing a lot more of that coming out now that we have the MCI being specified in some of these schemes.
Thank you. We've got 3 more questions and already over time. So I'll attempt to answer 2 of them. Which life cycle impact allocation approach is used here? We're not actually doing life cycle assessment in the tool. We're using some figures for carbon, which come out of EPDs. So we are using basically what has been prescribed in the product category rules of the EPDs. Then there is one question from Anna. Are the different scenarios analysis charts part of the tool? Yes, they are.
Yes.
That's an easy one. Yes, they are included. Stefan asks the all-important and probably difficult to answer. What percentage would you classify as a product as having above average recyclability?
That's
It
yeah.
depends, but I'll leave that to
That is the common answer, isn't it? It depends, and it really does depend. It depends on which materials you're using and which markets you're using them in, because recovery rates are regional as well. One of the things you can do with the MCI tool is to account for regional variability. So you can look at the same product in different markets and look at how the overall MCI is when you're sending the same product to different markets, and that can help inform the choice of materials you use, because really you want to select materials that are recoverable in the markets that you're selling them on. But you can look at multiple markets within the same tool as well.
And the final question is for Maria. How can the MCI guide businesses in taking responsibility for end-of-life impacts beyond their operational control? And again, I'll have an attempt in answering that because we just recently had a really good example from a company who make tissue products and hand towels, like those paper hand towels. And it wasn't so much the MCI, but they don't have any control of what happens to a hand towel that you use in an office building or in a hotel or somewhere. But they have published data. They've worked out where can paper reduce, or how can you reduce the scope 3 carbon footprint of those hand towels. And it is in the end of life, it's in the composting. So what they have done is they went out with good communication and publication about that to educate their end users. And that, I believe, is the only thing you can do. You can only impact the beyond your operational control by making some decisions, but a lot of it is in communication and good
Mm.
education.
Yeah, very much so. So yeah, I mean the challenges with end of life recovery of products will show up in the waste reduction component of the MCI, and being able to point towards that challenge is an opportunity for collaboration and broader industry engagement to promote infrastructure and enablers that enable those materials to be recovered more effectively. But that type of collaboration is where I would generally point to as well, Barbara.
Thank you, Jim. Thank you to all of you for your really useful questions.
So our first question is from Jack. So Jack asks, when calculating the lifetime utility value of a product for MCI, what do you compare it against? I.e., would you compare a carpet's product's life against other carpets or other flooring materials such as lino, tiles, laminate, etc.?
Yeah, so that's covered by the MCI methodology. So the way it's designed, and this aligns with ISO 59020 as well. They've adopted the same approach as have other indicators, is to compare the lifetime of the product against a typical product of the same type. So if you're comparing, in your case, a carpet, you would be looking at the typical lifespan of a carpet, and you'd be comparing your product against that. So what you're looking to do is to show an increase in the utility of the product versus the typical. And obviously with time, we would hope that the typical value would creep up, which makes it harder and harder to use the utility function to score to score better, but that's been a deliberate feature of the MCI, because we want the focus to be initially on making products to last longer, and then to look at how we use less material and recover those materials better. But yeah, you'll be comparing it against a product of the same type, and we haven't provided data for that because there are obviously a lot of different products that we would have to go and find the values for. But it is up to you and your verifier to establish what a fair comparable product would be and what a typical life cycle for that would be. You can also use the utility function based on the number of uses as well. So if you have something that is part of a shared use model, and the example I always use is a drill. So, rather than 100 people going out and buying a drill, if they all hire a drill and share access to that, you can account for that utility through the number of uses as well. So the MCI also accommodates that type of utility.
Awesome. Thanks, Jim, and thanks for your question, Jack. We've got one more question here, or two more now. So we'll answer those two, and we may wrap up after that since we're at time. But Lena asks, how often is the backend data updated? And how is the quality of that data assessed and kept? Is there an indication of any uncertainties?
Yeah, that's a great question. So the data is something we're updating annually. So we're continuing to grow our knowledge base in terms of the recycled content of materials. As I said, the data that's included in there is a global representation. So it's not region specific, but that region specific data is something that we hope to get to in the future, to allow that better resolution of data as for different users in different markets. But that data will be updated annually. It won't be part of a free update. So if you want the data, there will be an additional cost at some point. But the ability to override that data with your own is there, so you can update that as often as you like. The calculation itself, as I said, is pretty stable. It came out 15 years ago, and we've done very little to it since then. And it was preemptively compliant with the ISO 59020 standard. So we've not really had to do anything to the calculation other than what we've needed to be able to provide that user influence chart, which is just partitioning bits of the calculation so we can represent different components separately.
Awesome. Next question is from an anonymous attendee. How can we compare the importance of MCI to other indicators such as...
Yeah, so it's part of the reason why the MCI doesn't incorporate those indicators directly. The first version of the MCI actually included things like global warming potential and critical materials risk and price volatility and toxicity. But we found that we could spit out an answer, but it didn't mean much. So that's why the MCI really focuses on the circularity of materials, because that was what we didn't have an indicator for. So, but it has always been intended to be used alongside other indicators such as global warming potential, carbon risk, cost, because these are all things that we're trying to deliver through circularity. So being able to understand where circularity and these indicators intersect is really important, and you'll see that in some of the graphics that XY plot I showed you earlier of embodied carbon versus MCI. You're specifically looking for anything that's in that top left-hand corner that has a low circularity and a high contribution to your carbon footprint, because those are the things that circular action are likely to have the best effect on. If you're able to shift those products more to the right, make them more circular, then you stand a better chance of recovering the embodied carbon in those materials and to reduce your carbon footprint through that. So you can do that directly within the tool using the data that's there, or you can do that as part of a broader activity if you're publishing your global warming potential within your EPD or your LCA. Then the MCI is a very simple add-on to that type of report, because you're using a lot of the same data and the same assumptions. There's very little additional information you need beyond what's already in an LCA.
Awesome. And we do have one more from Tom, and then we'll wrap up. So Tom asks, how can you get accurate users recycling data at a product's end of life, when for many products with 10+ year life, these decisions and behaviors could be years away yet? So it's a good question.
That is a great question. And it's part of the reason why that user influence chart is important. There is, as you say, a temporal aspect to circularity. What we're designing for is not necessarily what will happen in the future. What we tend to rely on at the point of publishing an MCI is the prevailing market conditions. So that would be looking at any specific recovery mechanisms that exist for your product, if you have a take back scheme or a user guarantee or a return scheme. Beyond that, we would be looking at which markets you're introducing the product to and what the recovery infrastructure for materials there is like. So what are the typical recovery rates for those materials? And we would use that to publish the MCI initially. Now, the user influence chart is one of those things that can then be revisited over the life cycle of the product or the project. So if you're looking at a building that's designed for 50 years and you take a decision after 40 years to extend the service life to 60 or 70 years, you have the data to be able to update that calculation to show how circularity has improved. Similarly, if the recycling infrastructure changes or you introduce a scheme to recover products that you didn't previously, that can also be updated to account for that. So it takes the MCI from being a one-use static metric into something that's more of a living, breathing metric that persists with your product and can be updated as the infrastructure changes or your use model changes, which is one of the reasons we wanted to do that, because that's the reality, right? So we're taking our best guess at the point of producing something, what the circularity of it is likely to be, but we need to accept that people are going to use products differently and need to know how their use will affect it. And similarly, the infrastructure will change over the lifetime of the products, particularly for long lifetime products, and we need to be able to account for that. So yeah, being able to update those figures and to talk about how circularity has changed and how we've influenced that change is a very important thing to be able to do.
Awesome. Thanks, Jim, for answering all those questions and for taking us through the MCI Pro. I'm sure that
some great questions.
Yeah, which is great. It means that people are interested and hopefully will go and download the tool and join the pilot program. So that's fantastic. So if you are interested, go ahead, sign up for our pilot program. You get access to the tool early in that pilot stage, and then it's incredible value because you know, when the full tool comes out, you know, the pricing for that will increase. But if you're a part of the pilot program, then you'll get that upgrade for no extra cost. So now is definitely the time to sign up and get involved, and you can reach out to Jim if you've got any questions. We'll send some follow-up information after this webinar. And yeah, looking forward to seeing it out in the world and being able to calculate MCIs all over the place. So thank you once again, Jim, and for everyone for attending, and have a great rest of your day.
Thanks, Em. Thanks, everybody.
We have many more webinar replays on a whole host of sustainability topics. You can check them out on our website and our YouTube channel.